define ocean acidification as a big problem for Maine for a couple different reasons. Cold water holds CO2 more readily, so because inherently we have cold water in the Gulf of Maine, we're off to kind of a bad start.
Okay, so the estuaries here have a natural cycle of acidity and basic conditions that fluctuates with the biological cycle and the seasons and everything else. On top of that natural cycle, there are human activities that make those cycles move farther in one direction or the other direction. And so the concern people have is that there's a gradual acidification of these cycles as they go up and down, but they have a longer slope to them over bigger pieces of time, and that's due to things such as atmospheric carbon dioxide or nutrient pollution.
You have freshwater runoff. So, for example, the northeastern part of the United States has had a 73%, I believe, increase in 1% storms. What that means is those are storms that have very heavy precipitation, and you got more runoff into the estuaries and coastal waters. And the fresh water associated with those runoff events is more acidic. It is less buffered. So that is a significant part of the ocean and coastal acidification.
And the way I look at it is it's part of an overall picture of climate change and the state of the health of the environment and the ocean.
To give some more background on the biochemistry behind ocean acidification, here's a short video from the Northeast Coastal Acidification Network.
The shores of Atlantic Canada and the coast of Maine, New Hampshire, and Massachusetts down to the tip of Cape Cod make up the boundaries of the Gulf of Maine. The Gulf is known the world over for its flourishing populations of shellfish, mammals, and seabirds. For hundreds of years, the Gulf's bounty has fed the region's inhabitants, provided thousands of jobs, and sustained the unique cultural character of its coastal communities. But as humans continue to burn fossil fuels to power our global industrial economy, the Gulf's marine ecosystem has become threatened by warming ocean temperatures and the changing chemistry of the air and oceans. While about half of the carbon dioxide burned from fossil fuels stays in the atmosphere, about 25% of it goes into the ocean, which is why we call it a carbon sink. The big problem is that when CO2 goes into the ocean, it reacts with seawater to form corrosive carbonic acid. As the carbonic acid breaks down, it releases hydrogen ions which combine with carbonate in the water, inhibiting the formation of the vital molecule calcium carbonate. Creatures like clams, lobsters, mussels, shrimp, scallops, oysters, sea urchins, and corals use calcium carbonate as the building blocks to form their shells. With fewer calcium carbonate molecules, they have to spend more energy for shell production, which hinders their ability to grow. And if the water gets too acidic, it could even dissolve their shells. Scientists also believe that the Gulf of Maine is especially vulnerable to acidification because of the complex flow of freshwater from the region's many large rivers, as well as cold freshwater from the Gulf of St. Lawrence and snow and ice melt brought down from the Arctic by the Labrador Current. Because carbon dioxide is more soluble in cold water and freshwater has lower concentrations of carbonate and calcium ions, the region's unique geography further exacerbates the acidifying effect. Scientists also worry about nutrient loading, which is when the waste nitrogen and phosphorus from sewage, livestock, fertilizers, and various industries run into the ocean, stimulating massive phytoplankton blooms. Excessive phytoplankton produces even higher levels of CO2 as they decompose, which makes the waters more acidic, especially around coastal mudflats and salt marshes where mussels, clams, baby oysters, and other sea larvae thrive. Rain and snowfall also increases the level of runoff that brings nutrients into the Gulf, and the warming climate is expected to bring even more precipitation to the region. With rapidly melting polar ice caps and more rain and snow, the Gulf of Maine shellfish could be facing a perfect storm of acidifying waters.
So about 4 years ago, the fishermen started asking us about ocean acidification. So it became my job to figure out the answers to their questions. And because the state is so heavily reliant on these shell-building species, we had an idea that we are going to be, from a socioeconomic perspective, really vulnerable if acidification is in fact as bad as we think it may be.
What got me involved in this issue was that we were experiencing significant production problems that were making us not a very dependable seed supplier. And what happened was, and prior to when we were experiencing this, just prior, a number of hatcheries on the west coast of the U.S. were experiencing major production problems. In fact, in the state of Washington, oyster farming is it's kind of like lobstering here in Maine. You know, it's a big fishery. And they were experiencing 75 to 80% reductions in production out of their hatcheries. I believe they were also seeing a reduction in natural recruitment of larvae, which means that any oysters that are out in the wild that are spawning, and then those larvae grow and settle out, that's called natural recruitment, and they were seeing a decline in that as well. I don't know if anybody actually linked that to ocean acidification, but it was simultaneous with all this other stuff. So we actually were visited by two people from a hatchery out there who described the observations they were making with their oyster larvae. When we listened to that, there were many things that were so similar to what we were seeing that it made us decide that we needed to look at that.
I've been lobstering a little over 30 years. I guess. To me, it's a scary thing because it can affect things way down on the food chain, I mean, at the very basis of the ocean food chain and things like that, and may eventually be proven to affect lobsters in the long run. There was the big year that it kind of hit everybody in the head was that 2012 when we had a big warming occurrence in the Gulf of Maine, and that the shed or the molt happened. That it was almost 4 weeks early, so and that is highly significant to these fishermen because they're so set on, their grandfather told them that, July 2nd, this is when you set your traps, because it was down to that sort of specifics of a day or around the 4th of July or blah blah blah, so so that was kind of an awakening for the industry.
From a socioeconomic perspective, we're also vulnerable because of the dependence that we have on shell-building species. And shell builders are going to be the first species to be impacted by acidification. So our coastal communities that are largely dependent upon lobsters, also shellfish aquaculture is growing in the state, and some mollusks are thought to be the ones that are going to be most heavily impacted by acidification, makes these communities pretty vulnerable. We don't really know yet that ocean acidification is going to negatively impact lobsters. Some recent work has shown that warm water is going to be much more of a problem than acidification, but it's unlikely to be a good thing.
And so it's affecting plankton, and right up to and then when you get a little bit larger, you have these pteropods, copepods and things like that, which are actually, when you magnify them, they're actually like little snails or little shelled creatures and stuff, some of them are. So like they're already, even when you're in an almost microscopic sort of state, you're already dealing with creatures that are shell-building creatures, which are the ones that can be extremely affected by acidification in that double sense that it dissolves the acidified waters could dissolve the shells, and B, it sucks the chemical reactions take the compounds they need for shell building out of the system.
So there's concern about acidification affecting young of the lobsters in the same way that it might affect the young of the oysters. It's not clear that that's the major control on lobsters right now. Temperature is probably a bigger control.
So essentially what we did was we assumed that the way when you're in business and you're not doing a lot of research, what you have to do is make assumptions and then kind of test those assumptions by operating under that assumption. And if it works, then you ultimately assume that you're right? That would be kind of a commercial version of the scientific method. And that's what we did. So we made the assumption that our larvae were impacted by acidification problems, and we did a bunch of different things, developed a whole suite of strategies that made that assumption. And when we did that, and the key thing, as I said, was buffering the water, we really got not just improved results, but we got perfect results. What are how do we see ocean acidification? What are the causes of it? And one of the things that I believe is more important than has been really acknowledged in the coast of Maine here is the reduction in phytoplankton blooms and the amount of productivity. We've noticed when I started the business, we were constantly coming up and changing these filter bags, and over the last decade, it just hasn't happened. And we go through entire days during times of year when normally we'd be having these late winter, early spring blooms, and they just don't happen, or if they happen, that they're not as intense, and they only go for a day or so, and then it's done. So that obviously has an impact on carbonate chemistry. One of the things that we have as kind of a philosophical basis for our business is we believe in using technology to grow a naturally produced product. So we don't use a lot of chemicals, or we don't use antibiotics or any of that. And obviously when the oysters go out into the river, they're grown in a completely natural environment. But what we do believe in is, I think technology has the promise of helping us solve a lot of problems that humans have made for themselves. Basically, there's a light core gas analyzer in there, and this is the equilibrator where there's an airspace and they're sucking the air out of the airspace, drying it, and measuring the PCO2 in there. This is the Contrast alkalinity machine, and basically I think one of the things we're trying to determine is how the actual measured alkalinity compares to the calculated alkalinity from the salinity. We took data we collected using this in 2014, and it showed, we plotted omega versus time from like April through the end of June or into May, whatever. And then what we did was we said, okay, we've been in business for 30 years. Joe has this idea of how much carbon dioxide is dissolving into the oceans from the atmosphere, the increase per year, and his calculations show it's about 1.2 parts per million per year. So if you add or take out 36 parts per million for 30 years that we've been in business, you replot that curve to kind of say, well, what might it have been like, in those days? And then we did the same thing with the fresh water, where we know that it used to be that our salinities were consistently at 30 or better, and now we're seeing 28. So we took out 2 PSU and did the current calculation, and it's really does give you an idea how this kind of creeps up on you. Now, it's probably not strictly accurate, but it is an interesting way to kind of get at what it might have been like when we started out. One of the things that we will be doing, we haven't done yet, is sort of shifting over to a continuous flow larval system. But going back to the ocean acidification, we essentially change the water in these every 48 hours, and every time we change the water, we buffer the water coming in. So we don't really use the monitoring system for day-to-day management. We basically just have pH and pH meters and pH controllers, that kind of thing. But if we didn't do that, that has been the most stark impact of all of this for us, is that if we don't do that, our larval production goes down the tubes. I mean, it's not like we can't grow them, but we never know how many days it'll take us to get those larvae to go into metamorphosis. So before we did all this buffering and everything, we would have larval populations that could, some of them might go a normal 14 days and then go into setting. Some would go 3 or more weeks. Yes. And probably not the way we're configured now. But we're certainly looking at a lot of things that will, our approach and the things we're looking at, I believe will evolve into how shellfish are grown in the future.
We became involved at the Institute in mounting an effort to do something about ocean acidification and figure out the status of things in Maine and where the state of the science is. And so the 2014 Study Commission's task was to basically determine the state of the science around ocean acidification in Maine, tally up what is known about impacts on commercially important species in Maine, and make some recommendations about what we as a state can do to tackle the problem. So one of the recommendations, there were 6, one of the recommendations was about how to mitigate, remediate, and adapt to ocean acidification in Maine. And there were a couple specific goals within that larger recommendation that the Island Institute thought would be good pilot projects. And there were 2 that I'll mention. One was the feasibility of co-locating seaweed aquaculture with shellfish aquaculture, with the theory being that seaweeds that are photosynthesizing and taking CO2 out of the water column might be able to locally remediate the water chemistry, thereby improving it for shellfish growth. So if you put, for instance, a sugar kelp farm next to a mussel farm, can the sugar kelp locally remediate the water and improve the growing conditions for the mussels? So that was one kind of small project. At the time we thought it might be a small project. The other was another mitigation opportunity that has to do with recycling shells from shellfish and putting them back into the environment where they came from. Taking soft shell clam shells after they have been eaten by tourists, keeping the shells, grinding them up, putting them back out on the mud flat to buffer the muds, potentially improving the survivorship of juvenile soft shell clams. Because I'm working with Nicole Price at Bigelow Laboratory for Ocean Sciences in Booth Bay Harbor on a project with a kelp farmer named Paul Dobbins, whose farm is called Ocean Approved. So he has agreed to let Nicole and I deploy some sophisticated instrumentation that measures pH and carbon dioxide and dissolved oxygen and salinity and temperature at his farm. And again, the point of this project is to see if growing sugar kelp can remediate ocean acidification at a very local scale. So we think that through photosynthesis it can take up enough CO2 to potentially improve the carbonate chemistry of the surrounding waters, which might make a positive impact on shellfish growth. So thus far we have 1 season under our belt. The kelp growing season is actually in the winter. So Paul seeds his lines in November and then he harvests his crop in around May. And the kelp goes from being microscopic by the time it's seeded all the way to about 14 feet in length. So it grows very fast and it's very productive. And Nicole's laboratory work has shown that it's very good at taking CO2 out of the water. In fact, that as CO2 is becoming more abundant in the atmosphere, she's actually shown that the more we emit, the more it's going to take up. And out of 4 different species that she studied, it is the most effective at taking up more CO2 as there's more CO2 available to it. So our first season of research has shown some pretty promising results. We found that pH is actually higher inside the kelp farm up until a certain point at which the kelp slows in growth, and then the process of respiration actually takes over. So we've got net respiration happening as opposed to net photosynthesis, which is actually, so respiration is putting CO2 back into the water. So it would be important to figure out the timing at which you would need to take that kelp out of the water before you lose that phytoremediation benefit. Our goals for the next research season are to, number 1, get a second season of data to see if we can see the same positive trend of kelp actually having an impact. And Number two is then so basically we've got instruments smack dab in the middle of the kelp farm and then a couple hundred meters upstream. So we're measuring the water chemistry right around the kelp and then theoretically outside of this halo of remediated water to see the difference. And what we don't know is how big that halo is. So if there's this halo of better water around the kelp farm, how big is it? How long does it last? And is it different enough to have an impact on shellfish growth? So we know that kelp can have an effect on water chemistry, but okay, can it actually have an effect to the point where a mussel grower would say, hey, it makes a lot of sense for me to have kelp adjacent to my mussels because it's going to help my mussels reach market size faster.
We're in a very long historical sense, we're at the stage humankind went through many thousands of years ago with respect to land animals. So the sea animals fishing landings have been steady now for 10, 20 years, whereas the aquaculture landings have been increasing. So that means that we're already replacing the wild fishery with the cultured fishery.
It's conceivable to me that unless there are major efforts that are successful in reducing greenhouse gas emissions, I think it's possible that a lot of these fisheries won't be there unless they can be adapted and moved onto land where you can control the conditions.
I think it's going to be a mixture of wild harvest of the traditional fisheries like lobster and scallops, maybe not shrimp anymore, but combination of that with aquaculture and potentially some fisheries on new emerging species that we don't even have yet here in the Gulf of Maine.
We don't know what, if there's these farms up in the Kennebec and this sewer plant and this thing, what happens what happens when that in that estuary, when that river comes out in the ocean compared with somewhere else along the coast and things like that. So
I think we need to figure out a way to hasten the reduction of our carbon footprint. So that's the big one. We've got to reduce our carbon emissions as a society all around the globe. There are local things we can do to help here in the Gulf of Maine and in our estuaries, but for sure the big thing is reduction of carbon emissions.